All right, welcome back to the Allen Mentoring SAT Blue Book Every Question Explained. I apologize for the 1 week hiatus. I was on a project out in Connecticut, and unfortunately my portable streaming setup was not as effective as I thought. So I had to lug all of my lighting and webcam and drawing pad, and it turns out that the internet is not as fast as I thought it was. So streaming, I'm afraid, was impossible last week. So I apologize for that, and to make up for it, I'll try to be as high energy as possible today. We are on SAT Practice Test 3. So that is the third practice test in the official College Board Blue Book. If you want to follow along, I have a link in the description. All of the tests are available for free, provided by the College Board. Thank you, guys. And we will be doing section 4, which is the calculator portion. So if you missed any of the previous practice tests or section 3, which is the calculator or the non-calculator part, you can watch past videos. And as always, remember, please comment either in the chat or if you're watching a recorded video in the comments, and I will try to address every single question as best as I can. And if I notice that there's a pattern of common questions, I will try to maybe make a separate video just addressing that one topic. All right, so please try to be as active as possible, and that way I can give you content that I know my viewers really want. So let us start with question 1. And I'll try to get through the entire test. I can't make any promises. It's just Tuesday, so we're trying to save the voice for the entire week. But we'll try as hard as we can to get through everything. All right, so let's start with question 1. The graph above shows Marilyn's distance from her campsite during a 3-hour hike. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is closest to the time she finished lunch and continued her hike? Okay, so we see this is the distance from her campsite. So as time is going on, she's getting farther and farther away. All of a sudden there's a plateau, which leads me to think this is the 30-minute period that she went to have lunch. So they're asking, which of the following is closest to the time she finished lunch and continued her hike? Well, this is her lunch period here, and she seemed to have finished sometime around there. So it looks like about 1:45 or so. All right, 1:40 is the closest. All right, looks good to me. Let us move on. Is that number 2 up there? Okay. The table above shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability that the winner will be either a female under age 40 or a male age 40 or older? So when we deal with these probability questions, we need to think of the total sample size and then our target, okay? And probability can be represented as target, okay, over sample size or space. I'll put sample size, okay? And I haven't been here in a week, so the handwriting is even worse than normal, but don't worry, I'll get better as the stream goes on. So let's start with, what's our total sample size? I guess we are sampling the entire, all 25 people. Okay, so we're gonna see that our sample size is going to be 25, all right? And then we're asked, what is the probability that the winner will be either a female under age 40, okay, so female under age 40 is here, or a male aged 40 or older, so that's this. So let's think, what is our target? Well, we see we could pick either this or this, right? Which means they're both included in the target. So in our case, the target is equal to 10. All right, so if the target's 10 and the sample size is 25, our probability will be 10 out of 25. All right, and they probably could have reduced this, but I guess they want to make it easy because remember, the early problems in the sections are usually the easy ones, and they get harder and harder as you progress along. All right, number 3. The graph below shows the total number of music album sales in millions each year from 1997 through 2009. Based on the graph, which of the following best describes the general trend in music album sales in 1997 through 2009. Okay, so we see that year 0 is 1997, year 12 is 2009. So let's see. Just looking at it before even checking out the answer choices, right? I see that it kind of goes up until about 2001, then drops a little bit and keeps on dropping all the way until 2009. Okay, so sales generally increased each year. That is not true. Generally decreased, that's not true. Sales increased until 2000 and then generally decreased. So that actually looks pretty good because yeah, I said 2001, but it actually seems that right here is when it kind of spun down. Remain steady. So I'd say that C is the correct answer here. All right, let's look at number 4. The table above shows some values of the linear function f. Which of the following defines f? So they're pretty much offering us potential formulas that take us from n to f of n, okay? Because f is a function, so it essentially describes some sort of recipe, okay? So that recipe could be either n minus 3 to n minus 4, and then we plug in these ingredients, which are n, into the recipe, and we should spit out our final product, okay? So which of these, if you plug in n, will spit out the corresponding f of n? So n minus 3, let's see. 1 minus 3 is negative 2. 2 minus 3 is not 1, so that is out of here. 2n minus 4. So 2 times 1 is 2, minus 4 is negative 2. That looks good. 2 times 2 is 4, minus 4 is not 1, right? That would be 0, so that's out. 3 times 1 is 3, minus 5 is negative 2. 2 times 3 is 6, minus 5 is 1. That looks good. Then 9 minus 5 is 4. And then 3 times 4 is 12. Minus 5 is 7. So C is the correct answer. So that is just one method, which is guess and check. And I try to bring in several different methods for solving problems. So maybe if we come back to another function problem, we could solve it a slightly different way by perhaps seeing what the difference is between each subsequent f of n output. But in this case, guess and check is a perfectly legitimate tactic, and if you can use it, I suggest it. Okay, in the SATs, your goal is to get the highest score possible. It's not to prove to the teacher or to the score that you know how to actually do it, right? Whatever gets you the right answer is the right method in this case. So number 5. At Lincoln High School, approximately 7% of enrolled juniors and 5% of enrolled seniors were inducted into the National Honor Society last year. There were 562 juniors and 602. Which of the following was close to the total number of juniors? Total number of juniors and seniors. Okay. So we see that 7% of juniors and 5% of seniors. So really, we're just trying to find what is 7% of 562 and what is 5% of 602. Okay, so 7% of 562. Okay, so how do we do this? Well, my favorite method for finding percent of is switching the percent into a decimal. Okay, and the way that we do that is we move it 2 decimal places to the left. So we move it 2 decimal places to the left, and since we don't have anywhere to move, we put in a 0 here. So 7% is also known as 0.07. Of, we can translate to mean multiplication. So when you're finding of, a percent of something or a fraction of something, you can think of as being multiplication. So at the end of the day, we're trying to do 0.07 times 562, and then we're going to do 5% of 602. So it would be 0.05 times 602. And whatever we get here, okay, we will then add that to find the total number of juniors and seniors. So this is the calculator portion. So I will go to my handy dandy calculator, and let's see. So I had to do 0.07 times 562, and that will be about 39. And then 0.05 times 602. So that is 30, about. So if we combine these, we will get 69 as the right answer. Very nice. Alrighty, number 6. Which of the following is the sum of the two polynomials shown above? All right, this is pretty easy, right? All we want to do is combine like terms, right? And let's see if, as we combine like terms, if we can knock out any possible solutions. So let's start with here, 3x squared plus 5x squared. Well, that's pretty simple, right? They're like terms, x squared stays, and we add 3 and 5, so that'll get us 8x squared. So anything that does not have 8x squared, we can knock out right away. So we can knock out this and this. Now, what is the only difference between a and b? I see that this middle term is minus versus plus. So let's figure that out. What is minus 5x plus minus 2x? So when you add a negative number, right, all we're trying to figure out is what is minus 5 plus negative 2, right? So when you're adding a negative number, it's basically the same thing as subtracting, right? And to make that easier to understand, imagine if I told you, okay, well, you had $6 and then you added a loss of $2, right? You're adding a loss of $2. Well, you'd say, well, why would you go and say that entire phrase when you could just say, oh, you had $6 and then you lost 2, right? So here it's like saying we added a loss of 2. So we can rewrite that as minus 5 minus 2. Okay, and negative 5, so if you lost $5 and then you lost another $2, that means that you lost 7 in total. So in our case, it's going to be a minus 7x, and then we don't even have to check the minus 4. All right, number 7. If 3/5 w equals 4/3, what is the value of w? So 3/5 w equals 4/3. Okay, and just like any other algebra problem, you want to do the opposite to both sides. Okay, so what is happening to w? It's being multiplied by 3/5. So what is the opposite of multiplying by 3/5? That will be dividing by 3/5. Okay, and if you do it to one side, you must do it to the other side. Okay, so I'm dividing 3/5 on both sides. So what is 3/5 divided by itself? Just like any other number, it will cancel out because it will just be 1. So now w is equal to 4/3 divided by 3/5. 4/3 divided by 3/5. Okay, and to solve this, we just do keep, change, flip. We keep the first fraction, we change, so we're going to keep 4/3, we're going to change division to multiplication, and then we're going to flip the last fraction. Okay, and now we'll just solve 4/5 times 4/3 times 5/3, and that'll be equal to 20/9. Okay, and we just do numerator times numerator over denominator times denominator. So in our case, D is the correct answer. Okay, so far so good. Number 8. These are going to start to get a little harder now. The farther we go, the more difficult they get. Number 8. The average number of students per classroom at Central High School from 2000 to 2010 can be modeled by the equation y equals 0.56x plus 27.2, where x is the number of years since 2000 and y is the average number of students per classroom. Gotcha. Which of the following best describes the meaning of the number 0.56 in the equation? Okay, so is it the total number of students at the school in 2000? That's probably not it, because we see that it's being multiplied by every year, right? So it has to have some sort of relation with however many years passed. So that's probably not the total number of students, because that would be some sort of constant. The average number of students per classroom in 2000. Again, that would be y, right? Because y is the average number of students per classroom. So that's probably not it either. C, the estimated increase in the average number of students per classroom each year. Okay, that seems a little bit closer to what we're looking for, because we see that it relates to how something increases per year. Okay, and so let's look at D. the estimated difference between the average number of students per classroom in 2010 and in 2000. Okay, and so that's probably not it, because again, that seems like a constant, because it's the estimated difference between the average number of students, which is y, and between 2010 and 2000. So that is probably not it. And C seems to be the correct answer, because as you increase every year, that's how many students increase per classroom every single year. All right, and if you were to model this with a line, 0.56 would be the slope. Okay, and so that's kind of the rate of change per year. Alrighty, number 9. Let's see here. 1 second. Sorry. Let me just check one thing right quick. Okay, excellent. And I hope the lighting is okay. As of now, I have daylight coming in through the window and also a giant lamp. Hopefully, as the sun goes down but the lamp maintains, the color will be okay. Sometimes it gets a little bit too scary, like blue. So if I look too blue, just let me know. Okay. Number 9. Nate walks 25 meters in 13.7 seconds. If he walks at the same rate, which of the following is closest to the distance he will walk in 4 minutes? Ooh, I like this question. Okay, so how are we going to figure out, we know he walks 25 meters in 13.7 seconds. Okay, if he walks at the same rate, which how do we find out how many meters he walks in 1 minute? We know how many he does in 13.7 seconds, but how can we relate that to 1 minute? Well, we could set up a simple rate multiplication here. So we know that he walks 25 meters in 13.7 seconds. Okay, and so we see that I'm writing this as kind of a rate or a speed, right, in meters per second. And so you could do this for any unit. If it's, feet per minute, feet per second, millimeters per hour, right? You can write the speed as such. Okay, so now we want to multiply by how many seconds are in a minute. So we know that there are 60 seconds over 1 minute. Okay? And so now, if we look diagonally, we see that we have seconds and seconds diagonal from each other in the fraction. And if you have the same unit diagonal from each other in the fraction, you can actually cancel them out. And so what units remain? Well, we have meters on top and minutes in the denominator. And so after we complete this multiplication, we'll have meters on top per minute, which is perfect. Okay, so let's do this here. 25 times 60, and let's use our handy dandy calculator. 25 times 60 is 1500 over 13.7 times 1. I don't need a calculator for that. All right, so this, if I do 1500 divided by 13.7, so that'll have be about 109.5. And so this is our speed in meters over minutes. We see that because these are the only 2 units remaining. But we don't want to know how many meters it is in 1 minute. We want to know how many meters it is in 4 minutes. So since I know this is since I know it's 109.5 meters per minute, all I have to do is multiply this by 4, and that'll tell me how many meters in 4 minutes. And so the closest in this case is 450 meters. Okay, and this method is actually really useful for all sorts of rate problems. If you have to convert like feet per second into miles per hour, you could use a very similar rate fraction multiplication system. Just make sure that the rates that you want cancel out diagonally. Okay, put them in such a way that they'll all cancel out diagonally. All right, number 10. So this is this is planets and acceleration due to gravity. Okay. So the chart above shows approximations of acceleration due to gravity in meters per second squared. For the 8 planets in our solar system, the weight of an object on a given planet can be found by the formula W is equal to mg. Okay, so far so good. All right. So this is essentially, so it tells us G is the acceleration due to gravity. So these are the G terms here. Okay, all of these are representing G. Oh, where am I going? So what's the question? What is the weight in newtons of an object on Mercury with a mass of 90 kilograms? 90 kilograms. And we see that M is the mass of the object in kilograms, and G is in this graph here. And so W, why are my W's so ugly? W is equal to 90 times the G that we're looking for. And we're looking for Mercury. So Mercury is going to be 3.6. Okay, and so 90 times 3.6, 90 times 3.6 is 324. Excellent. Okay, an object on Earth has a weight of 150 newtons. On which planet would the same object have an approximate weight of 170 newtons? So if we see here, the object itself, the mass is not going to change. Right, so the only difference that we care about is the acceleration due to gravity, right, which is represented by G. So we want to see which of these G accelerations due to gravity has the same ratio as 170 to 150. Okay, so let's see. So 170 divided by 150 is equal to 1.133. So we want to know which of these other accelerations is 1.133 bigger than Earth. And so we see Earth is 9.8. If we multiply 9.8 times 1.133, okay, we want to find the one that has about 11.1 Gs in this case. And so that will be Saturn. Okay, and I hope that was a little bit clear. Maybe I went too fast on this number 11, but just understand that since the mass of the object doesn't change, the only thing that would contribute to it being more newtons is a higher acceleration due to gravity. Okay, and so the ratio should be the same between 170 and 150, and 11.1 and 9.8. Number 12. If the function f has 5 distinct zeros, which of the following could represent the complete graph of f in the xy plane? All right, so really all this is testing is if we know what zeros are. What are zeros? Well, zeros are where the graph goes through the x-axis. Okay, so here's an example of a zero right there and right there. All right, and why is it called a zero? Because at this point right here, the y value is equal to 0. So it's essentially the point on the graph where y is equal to 0, aka where it goes through the x-axis. So you can think about it either way. So which of the following has 5 places where it goes through the x-axis? I see 1, 2, 3, 4, 5, 6. Oh man, no. All right, 1, 2, 3. Is that going through? 4, 5. That looks good. 1, 2, 3, 4. 1, 2. Wait. 1, 2, 3, 4. Okay. So D is the correct answer. You got to be careful sometimes. All right. Don't rush through these, especially for ones that I think are pretty easy and you probably think they're easy too. Just make sure you're looking at all 4 choices and selecting the correct answer. Don't make any stupid mistakes on the easy ones. That would be embarrassing. All right. 13. The equation above gives the height, h, in feet of a ball t seconds after it is thrown straight up. So if you've been working with me for these past 3 practice tests, you've already seen this equation in some form or another. All right, so a lot of these problems will not be new to you, especially if you go through all of the practice tests. I guarantee at least 70 to 80% of the questions you will have seen in some form or another. Those 30% are really the ones that are going to challenge you, but most of them, if you work through this, you will have already seen. All right, so pay attention to each of these questions and try to do them on your own without my help. So 13. The equation above gives h in feet of a ball t seconds after it's thrown straight up. Initial speed of v per second. Okay. Which of the following gives v in terms of h, t, and k? So really, we don't need to even know what any of this means. All we're trying to do is isolate v, which is a problem that we've done maybe 10 times already. Okay, so what are we going to do? We're going to try to get all of the other variables to the other side. Okay, we're going to try to get it all the way to the other side and leave v by itself. And the way that we're going to do that is by doing the opposite to both sides, just like any other algebra problem. So let's start with maybe getting this k out of there. So let me rewrite this. H is equal to negative 16t squared plus vt plus k. Okay, so the first move we're going to do is subtract k out of here, and we're going to do it to both sides. Okay? Next, we're going to do the opposite of negative 16t squared. Right? So if you think about it, vt is subtracting by 16t squared. So the opposite of that would be plus 16t squared. Okay? All right, so I'm going to add that also to the left side here. Okay, cross this out. So if I was to rewrite this without getting too far, it's h minus k plus 16t squared is equal to vt. All right, so the last step is to isolate v. So what is happening to, what is t doing to v? It's multiplying. So the opposite would be dividing t on both sides. So we're going to divide it by the entire left side here. So this cancels out. And so now we see that v is equal to h minus k plus 16t squared. And I don't see that in the answer choices. So what's happening here is that they're actually separating the division of h minus k divided by t and 16t squared divided by t. So what I mean by that is you can rewrite this as h minus k over t plus 16t squared over t. So this right here is the same exact thing as this. All right, we're just separating them into two separate fractions. Okay? So which one of these is equivalent? Well, if you have 16t squared divided by t, t squared divided by t will equal just t. Okay, why is that true? Well, if you have t squared, that's basically saying t times t over t. Okay, t times t divided by t, right? You can just knock off these two right here, and so t remains. And so now the answer will be h minus k over t plus 16t. Alrighty. Number 14. The cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following represents equation represent the total cost C in dollars for H hours of phone use? H hours in phone use. Well, we know if it's 20 cents per minute, then in order to find out how many cents or dollars per hour, we would just do 0.20 times 60. Oops, sorry. Times 60. Okay, because 20 cents per minute times 60 minutes will get you how many dollars per hour. So now we want to see 20 cents per minute. So let's say, for example, it's going to be H is equal to 4 hours, as an example. Okay, how would we find out what the total cost is? Well, we would want to take those 4 hours, multiply it times whatever the cost is per hour, which is 20 cents times 60. So really, all we're doing is H times 20 cents times 60 minutes. And that is represented by A right here. Okay, and if you wanted to do it a different way, you could have found out what was the total cost. So for example, in this case, I know if it's 4 hours, it's going to be 4 times 20 cents times 60 minutes. And so let's say that would be equal to 4 times 0.2 times 60. And I would see that's equal to $48. And so what you could do is check each of these solutions for 48. So whichever one equals 48 will be the correct answer. So that's actually another legitimate way to do it and one of my favorite ways to solve SAT problems. So it's up to you now if you want to abstract it versus plugging in your own numbers. Okay. So far, so good. All right, and let's see how many questions we have left until the short answer portion. 22. Okay, 28. Okay. Awesome. So 30 questions. So we'll probably take a break at around question 18. We'll take a little break. All right, so we are now on question 15. Let's move on. In order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. Half the participants were randomly assigned to receive treatment X, and the other half did not receive treatment X. Okay, so half received it, half didn't receive it. The resulting data showed that participants who received had significantly improved eyesight compared to those who did not receive. Okay. Based on the design and study, which of the following is an appropriate conclusion? All right. So let's first check if this is a legitimate study. So we have 300 participants. Okay, so that's good. Sample size is pretty solid, right? Anything above 30 to 50 is a good sample size. Now, what about the location of the sample? Are they all selected out in one, random school or one random restaurant? Sometimes you see those problems. In this case, it seems that this is 300 participants from a large population. So it seems like the sample size is good. The resulting. Okay, so I'm thinking this is a legitimate study and that treatment X does help the patients improve their eyesight. So A, I'm thinking is correct so far. Treatment X improves eyesight better than all other available treatments. Well, they did not talk about any other available treatments. Treatment X will improve the eyesight of anyone who takes it. That's not true because we see that only people with poor eyesight were surveyed. Treatment X will cause a substantial improvement in eyesight. That is not true as well because, again, it only refers to people who already have poor eyesight. So if you have 20/20, it's not like it's going to take you to 20/10 or something like that. So A is the correct answer. All right, 16. Graphs of the functions f and g are shown in the xy plane above. For which values of x does f of x plus g of x is equal to 0? So let's look, for example, at A. F of -3 plus g of -3. So what is f of -3? The way we find that out is we look at the x coordinate of -3. So that'll be -1, -2, -3, which is right there. And we see, okay, what is the y value at -3 of this graph? So f of x is this parabola right here. And we see that at -3, it's going to be equal to something like -1. Okay, so f of -3 is equal to -1. And g of -3, that's the graph right here, we do the same thing. We look at -3 on the x-coordinate, and we see what g of x is equal to there. That's going to be equal to also -1. All right, so -1 plus -1 is not equal to 0, so that is not the correct answer. So that's pretty much how we do this problem. Let's look at -2. At -2, f of x, so here's -2, f of x is equal to about -2, and g of x is equal to +2. So -2 plus +2 is equal to 0. So this seems to be the correct answer here. All right, and all of these f of x graph problems are done the same way. You locate the x-coordinate and then see where the graph goes through on the y-axis. Okay, 17. Refer to the 1718, refer to the following information. Okay, the quantity of product supplied and the quantity of the product demanded in an economic market are functions of the price of the product. Gotcha. The functions above are estimated supply and demand functions for a certain product. Okay, S of P gives the quantity of the product supplied, and D gives the product demanded. Okay, and P refers to the price. Okay, so price is P dollars. All right, so far so good. So how will the quantity of the product supplied to the market change if the product is increased by $10? Okay, so that is right here. So what are we going to do? Well, let's write this equation here. S of P is equal to 1/2 P plus 40. Okay, so basically it's saying what would happen if the price, what would happen to S if you increased P plus 10? So we could do it multiple ways. We could, solve it algebraically, solve P of 10, or sorry, plug in P plus 10 and solve it that way. But I want to actually do a more practical solution. Let's just select two prices. Okay, so let's say P was $10 at first, and then P became 20, right? Increased by 10. You could just plug that into the equation and see what the difference is at the output. Okay, so plug in 10, plug in 20, and then see what the difference is at the end. So let's plug in 10. So 1/2 times 10 plus 40 is equal to, well, 1/2 times 10 is 5, plus 40 is 45. 45. Okay, now what would happen if you plugged in 20 into that equation? 1/2 times 20 plus 40 equals, so 1/2 times 20 is 10, and add 40, you get, 1/2 times 20 is 10, plus 40 is 50. I had like a brain pause. Okay, so the quantity supplied will actually increase by 10 units. Okay, and we know that for sure. It's really easy to see here, right? You just add 5. Now, what would happen if you had done it maybe algebraically? You could have looked at it and said, wait a minute, well, half of P, so it goes from 10 to 20, so pretty much it just increases by 10, or you could have maybe made, a brain pause yourself and kind of got the algebra wrong. In this case, it's pretty hard to get this wrong, and which would be pretty embarrassing if it is wrong, so I hope it's not wrong. But using your own numbers gets closer to guaranteeing that your solution is correct. 18. At what price will the quantity of the product supplied to the market equal the quantity of product demanded by the market? So pretty much what they want us to do is find out at which P value will these two equations be equal to each other. So when will S of P equal D of P? And so what we can do is we can just replace S of P and D of P with their equations, right? So we can say 1/2 P plus 40 is equal to 220 minus P. All right, so we're setting these two equations equal to each other, and we just want to solve for P. So let's get all of the P's to one side and all the numbers to the other side. So how do we get this P to the other side? So if we're subtracting P, we're going to add P to both sides, right? We're doing the opposite to both sides. So we're going to add that to both sides. And what is 1/2 P plus 1P? 1/2 plus 1 is equal to 1.5 P plus 40 is equal to 220. We're going to subtract 40 on both sides. And now you get 1.5 P is equal to 220 minus 40, I believe, is 180. Okay, could be wrong. And then we want to isolate P by dividing 1.5 on both sides. All right, and so now P is equal to 180 divided by 1.5. That is equal to 120. Boom. Awesome. So as I said, we're going to take a little break here on number 18. I'm going to come back with a vengeance. Number 19. I'm going to keep the energy up. I'm going to keep on getting right answers. I hope. I don't have the answer key in front of me today, so I'm kind of just freestyling. Hopefully all these are correct. If they're not, just be nice. Write in the comments. And by the way, if you subscribe, I will be doing surprise subscriber lessons. So usually I'm on Tuesdays and Thursdays from 7 to 9 p.m. But for subscribers, I will pick a random day, random time. Like it could be, Wednesday at 6 p.m. And only the subscribers will get an email or some sort of notification that tells them that the session is live. So if you want to subscribe, there actually is a benefit, not just to help me out, but also if you want to talk to me in a more intimate setting where there won't be as many people watching, that's a great idea for you. So I'm gonna put 10 minutes on the clock, and I will be back. That I promise you. So let's see here. Let me put 10 minutes on the clock. Set timer for 10 minutes. Okay, and then let me bring in a little window there. Bear with me, bear with me, bear with me. Okay, looks good. Doesn't have to be perfect, but I will be back, promise. And then we'll finish up this test, or as far as we can get in it. So I'll see you soon. All right. Thank you for sticking around. I have my pen here. So I'm probably going to finish the multiple choice part of this test. And then on Thursday, that is August 3rd, I will be completing the calculator short answer portion. Okay, so we will be working until question 30, I believe. And then you could come back on Thursday and finish up the short answers portion. Okay, so no more talking and stumbling and mumbling. Let's get on to number 19. Graphene, which is used in the manufacture of integrated circuits, is so thin that a sheet weighing 1 ounce can cover up to 7 football fields. Is that true? If a football field is an area of approximately 1 1/3 acres, how many acres could 48 ounces of graphene cover? Okay, so it's not too bad. So we know 1 ounce covers 7 football fields, and each football field is 1 1/3 acres. So 1 ounce can basically cover 7 times 1 1/3. So let's see what that is on the handy dandy calculator. So 7 times 1 1/3. And so 1/3 as a decimal is 0.33333333. So we would do 7 times 1.33333333 repeated. That'll get us about 9 1/3. Okay, so 1 ounce can cover about 9 1/3. So how many can 48 ounces cover? So we will multiply that by 48. That'll get us about 450. Boom. Flying through. Flying through. All right, number 20. Michael swam 2,000 yards on each of 18 days. It's a lot of yards, it's a lot of days. The scatter plot above shows his swim time for and corresponding heart rate after each swim. The line of best fit for the data is also shown. That is this line here. For the swim that took 34 minutes, Michael's actual heart rate was about how many beats per minute less than the rate predicted by the line of best fit. So at 34 minutes, so that's this one right there. So that's right about here. So the heart rate per minute of the best fit line is exactly 150. And Michael's is, how many lines is this? 140, 1, 2, 3, 4, 5. Okay, so each of these horizontal lines represents 2 beats per minute. And so it's 1 line away. So it should be 2 beats per minute. Okay, did that one a little fast, so I hope my eyes aren't failing me. I'm 21. Of the following 4 types of saving account plans, which option would yield exponential growth of the money in the account? So before even looking at the solutions, how would you yield exponential growth? Chances are you would want to compound the money that you have. So if you have, whatever, 20 bucks, right, it increases by 10%, then whatever that new amount is, you want to increase that by 10%, and that's kind of what will be exponential. You want to be increasing on the compounded amount, so it gets bigger and bigger and bigger and bigger. So each successive year, 2% of the initial savings is added to the value of the account. So it seems that this might be exponential, but if you think about it, the initial savings is just the same number, right? The initial savings, let's say it was $20 in initial savings, you're just adding 2% of $20, which will be the same amount every single year. Okay, so that is not exponential. Each successive year, 1.5% of initial savings and $100 is added. Again, this is not exponential because you're adding the same amount every time. It's 1.5% of the $20 plus $100. So that's not exponential. Each successive year, 1% of the current value is added to the value of the account. So this is closer, and actually is the right answer, because we are adding 1% of the current value to every single year. Okay, so as that amount gets bigger, the amount added gets bigger, and that's why it's exponential. Okay, the sum of 3 numbers is 855. One of the numbers, x, is 50% more than the sum of the other two numbers. What is the value of x? This is an interesting problem. I would say maybe the first quote-unquote tricky one that we've gotten all day. All right, so let us handle this. So let's represent the three numbers as x, y, and z. So we know that the sum of them is 855. What else do we know? We know that x is 50% more than the sum of the other two numbers. So x, let's translate that into math. X is equal to 50% more than the sum of the other two numbers. So if we take 1 y plus z, it's 50% more than them. So how would you represent 50% more right here as a coefficient? Well, it's whatever y plus z is times 1.5, right? Because it's a half more than. Okay, so it's y plus z times 1.5. Okay, so let's say, for example, y plus z was 100, then 100 times 1.5 is 150, and so that is 50% more than 100. Okay, so now what do we want to do? We have these two equations, and we somehow want to find out what x is equal to. All right, so I think our move is trying to substitute y plus z, you see that right here, y plus z with some sort of x. Okay, and how are we going to do that? Well, if we isolate y plus z in the second equation, we would divide it by 1.5 on both sides, right? The opposite on both sides. We see that y plus z is equal to x over 1.5. Aha. So now we can rewrite this first equation as x plus x over 1.5 is equal to 855. Do you see how we substituted the sum of y plus z in the form of x? So now we're actually dealing with only one variable and one equation, and this is totally solvable. But it's still not, a piece of cake. There could be mistakes made. So how do we solve this equation here? Well, the annoying part is that we have a fraction right in the middle of our algebra problem. We probably want to get rid of this fraction. So what do? We want to multiply all of the terms in this entire equation by the least common denominator. And so the least common denominator is 1.5. It's actually the only denominator. So we can multiply the entire equation by 1.5, and that will clear out this fraction here. So let's do that. Let's distribute 1.5 to every single term in this equation. So 1.5x plus, what's x over 1.5 times 1.5? This cancels out and it just becomes x. And what is 855? 855 times 1.5. That'll be about 1282.5. And so what is 1.5x plus x? That'll be 2.5x is equal to 1282.5. And now to isolate x, we'll just divide both sides by 2.5. All right. And so now, what is 1282.5 divided by 2.5? That'll be about 513. Whoo, very nice. I thought for a second we might not get the answer. All right. Let us continue. Let me move this here. Okay, this should be good. Okay, the angles shown above are acute, and sine A degrees equal to cosine B degrees. If A equals 4k minus 22 and B equals 6k minus 13, what is the value of k? So what are they trying to show us by telling us that the sine of A is equal to cosine of B? So if sine of A is equal to cosine of B, that means that these two are complementary angles. Okay, so if you see this in future problems, understand that's what they're trying to push you toward. Okay, so sine of A is equal to cosine of B. So A plus B will equal to 90 degrees. So all we have to do is set up the equation A plus B, which is equal to 6k minus 13, is equal to 90. All right, so let's combine like terms. 4k plus 6k is equal to 10k. Negative 22 minus 13, so we lost 22 and we lost 13 more. That will be equal to minus 35, is equal to 90. And now let us isolate 10k by doing the opposite to both sides. So 10k is equal to, I believe, 125. And then isolate k by dividing on both sides. And what is 125 divided by 10? You just move the decimal place one space over. So that is going to be 12.5. All right. Okay, getting to the pretty difficult ones now, right? We don't have too many left. We only have, that's it, right? 6, oh no. 1, 2, 3, 4, 5, 6, 7. Okay, so these are going to get a little tough. Now, if you're taking the real test and you see some of the problems are way too hard, what I want you to remember is once you get to the short answer portion, okay, so once you get to this portion right here, these questions start getting really easy again. So the smart move is work through the multiple choice questions until they get a little bit too hard. You know, if you're like taking, you know, a minute on each problem, then it means it's a little bit too difficult. So what you want to do is you want to leave those blank for now. Go ahead to the short answer. Do as many of these as you can. And then if you have time, return back to the multiple choice. Now you never, ever, ever, ever want to leave anything blank. Okay, you do not get penalized for writing a wrong answer. So at least bubble something in for all of your choices. But yeah, if it's a little bit too hard, go to the short answer and they'll be easy again and then you can come back. So 24. Mr. Cole has a beaker containing n milliliters of solution to distribute to the solutions in his students in his chemistry class. If he gives each student 3 milliliters of solution, he'll have 5 milliliters left over. Okay, in order to give each student 4 milliliters of solution, he'll need an additional 21 milliliters. How many students are in the class? Ah, okay. So I see here that we have two variables, right? We have, the first variable is n milliliters, and then we have how many students, right? And we can make that s. So we have two variables, and he gives us two different situations, which means we have two variables and two equations. So if we can set that up, we can solve for both variables. Okay, so let's see here. Let's set up this equation. So if he gives each student 3 milliliters of solution, okay, so 3 times s, he will have 5 milliliters left over. So if he gives each of them 3s plus the 5 that is left over, we'll see the total amount of milliliters n. Okay, I hope that makes sense. Each student gets 3 plus there's 5 left over, so that's the total. In order to give 4 milliliter solution, okay, so if he gives 4s, he will need whatever is in the beaker plus 21 milliliters more. Okay, so in the first case, he had 5 left over, and that equals whatever's in the beaker. And then if he gives 4, he'll have to take whatever's in the beaker plus 21 to supply everybody. So these are our two equations. And so we can solve this using substitution. So we see here that n is in both equations, and n is equal to 3s plus 5. So in my second equation, if I rewrite this, 4s, I can replace n with 3s plus 5. Okay, and that is a substitution method of solving a system of equations. Okay, 4s is equal to 3s plus 5 plus 21. All right, and now let's isolate s. So I'm going to subtract 3s on both sides. And we have S is equal to 5 plus 21, which is 26. Very nice. All right. All right, let's look at number 25. A grain silo is built from 2 right circular cones and a right circular cylinder with internal measurements represented by the figure above. The following, which is close to the volume. All right, so all this is really challenging us to do is remember what the volume of a cylinder is and a volume of a cone. Now, if we go back to the beginning of this test, I believe they tell you, they give you some helpful equations. So right here, they actually give you the equation for a cylinder, which is pi r squared h, and the volume of a cone is 1/3 pi r squared h. So a cone is kind of like a third of a cylinder. You can imagine 3 cones next to each other get you a cylinder. So knowing that, let's find out the volume of the cylinder first. So the volume of the cylinder is equal to pi r squared h. So it's going to be pi r squared is 5 squared, right? 5 is the radius, so it's going to be times 25 times h, which is 10 feet. Okay, and the volume of our, I guess cylinder and cone both start with C. So the volume of the cone is going to be 1/3 pi times r, which is pi r squared. So it's going to be basically the same thing, just a third of that. And so we have 2 of these guys, right? So let's figure this out. So if we go to the handy dandy calculator, we actually don't need it for now. Let's figure out what the cylinder is, which is 250 pi. And this one will be 1/3 250 pi. Okay, except it won't be 1/3, it'll be 2/3 because we have 2 cylinders, right? So we multiply that by 2. So now let's figure out what 2/3, 2 divided by 3, 2/3 times 250. Okay, so that's 166.666 repeated. Okay, we're gonna multiply that by pi, and I'll estimate that 3.14. Okay, so that's 523 for the cones, and then 250 pi for the cylinder. So that's 785. Oops. Where did my mouse go? Oh, sorry. 785. And so we'll add that to 523. So that's 13. Was that? I can't even read my own handwriting now. I think. Wait, let me do 250 times 0.66666 times 3.14. 523 plus 785. So it's 1308. I think this is correct. Oh, okay. Sorry. See, I made a mistake here. So my cone does not have a height of 10 feet. You see this? This is actually supposed to be 5. I didn't realize that these cones. Okay. So really what I should have done is 1/3. This should be actually 1, right? Because instead of 10, I'm having that. It's going to be 5. So this should be 1/3 250 times 0.33333 times 3.14. So it's going to be 261 plus 785. 1046. Okay. Sorry, guys. That was my bad. And see, I went a little bit too fast. I didn't look at the graph. I didn't look at the picture. I'm going to try to rush it. So that's a lesson. Learn from me. Learn from my mistakes. And that way, you won't have to make the mistake yourself on the test. 26. In the xy plane, the line determined by the points 2, k, and k32 passes through the origin. Which of the following could be the value of k? Aha, so this is a little tricky, but basically what we know is that these 2 points form a line. Okay, so we see that 2k and k32, okay, the line goes through the origin somehow. So what we know is that the slope of this line right here and the slope of that line right there are exactly the same, right? It's a straight line. So the slope between any of the points on that line will be exactly the same. So what we want to do is maybe find out what the slope is between this point and the origin, and then relate that to the other point here. So what is the slope of between 2 comma k and 0, 0? Okay, and the way that we do that is we do the difference of y over the difference of x, also known as rise over run. So what is the difference in the y coordinates? So we have k minus 0 divided by 2 minus 0. That'll be equal to k minus 2, or k over 2. So k over 2 is the slope of this line. So now how do we relate k32 to the origin? Well, we'll do the same thing. We'll do 32 minus 0 over k minus 0, so that's equal to 32 over k. So this is the slope of between k32 and 0, and this is the slope between 2k and 0. But we know that these two slopes are exactly the same, right? So we could say that k over 2 is equal to 32 over k, right? We know those two slopes are equal. So how do we solve this fractional equation? Well, we do cross multiplication. All right, we know that k times k is equal to 32 times 2. So k squared is equal to 64. And if k squared is equal to 64, then k must be equal to 8. Bam. All right, and so actually while I was doing this, my flux turned on to preserve my eyes. So let me disable that really quickly. Okay, because that's making the cursor a little harder to see. Okay, so sorry about that. 27. A rectangle is altered by increasing its length by 10% and decreasing its width by p%. If these alterations decrease the area of the rectangle by 12%, what is the value of p? All right, so this is one of those problems where you can do it in a few ways. One is by choosing your own numbers. Another is algebraically. And maybe just to make things a little bit interesting, we'll try to solve this algebraically, so your teachers will be happy, and maybe this will help you for harder problems in the future. So let's see. So we know that the area is equal to length times width. Okay. So it says that the length is increased by 10%. So how do you represent an increase of 10%? Similar to how we did an increase of 50% was 1.5, an increase of 10% will be 1.1 times L. Okay? And then we are decreasing its width by p%. Okay? So we're going to be multiplying it by decreasing its width by p%. So it's going to be 1 minus 0.01 p times w, right? So if p, let's say, was 10%, or sorry, yeah, if p, for example, was 10%, then we would multiply 10 times 0.01, that would be 0.1, and so 1 minus 0.1 will get you to 0.9, so that's a decrease of 10%. 20% will be 1 minus 0.2, right, which will get you 0.8. So that actually looks good. So they're asking if these alterations decrease the area of the rectangle by 12%. Okay, so now we're trying to find out by 0.88a. Okay, what is the value of p? What is the value of p? Okay, so how do we solve this? Well, first thing we want to do, right, is we want to distribute w here. Okay. All right. Sorry, wait 1 second. All right, so we're back. Sorry for the interruption. Okay, so where was I? 0.88a is equal to 1.1 L times W. Okay, so what we want to do is we want to relate A and LW, right? So if I rewrite this bottom equation here, 0.88a is equal to 1.1 times 1 minus 0.01p times LW, right? All I did was I switched this around to put it right there. Okay, so I just rewrote this equation here. We know that LW, length times width, is represented by A, right? So I could just replace LW. I could replace that with A. Do we see that? If A is equal to LW, I can change LW to be A. And so now we see we have 0.88a is equal to this whole mess times A. And so now we could also divide A on both sides. We can divide A on both sides. Bam, bam. So now we have 0.88 is equal to 1.1 times 1 minus 0.01p. Okay, I hope that makes sense. And so this is why doing it purely algebraically is sometimes a little tricky, right? Because if you mess up one little part in this equation, the entire problem will be wrong. So now we have to isolate p. So what do? As always, the opposite to both sides. So we're going to divide by 1.1. So what is 0.88 divided by 1.1? That's going to be equal to 0.8. Okay? And that'll be equal to 1 minus 0.01p. So now we want to subtract 1 on both sides. And we know that 0.8 minus 1 will be negative 0.2. And negative 0.2 is equal to negative 0.01p. And if we divide both sides by negative 0.01 over negative 0.01, this cancels out. And 0.2 divided by negative 0.01 is equal to 20. So P is equal to 20 in this case. If the algebraic method was too complicated, you could also try by plugging in your own number. You could say, okay, so the length of the rectangle is 10, and then you can change it to be 11, right? Because it increases by 10%. And then you could plug in, try to find out what value of P would actually make it work if you were to decrease it by that much percent. All right, so you could also try it by using your own numbers here. Okay, 28. In planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. If the present population of the city is 50,000. All right, so this is a simple interest problem or simple growth decay problem, and we know that is equal to 1 plus r to the t. Okay, and so in this case, it's going to be r is going to be equal to negative 0.1, right? Because it's decreasing by 10%. So we see that in this parentheses, we should have 0.9. So we'll knock this out and knock this out. Okay, so the question is every 20 years. So 2 years from now. Aha. So we know that when t is equal to 20, that is when we want to get the full increase, or sorry, the full decrease of 10%. So when t is equal to 20, that will say 20 years from now, okay? And every 20 years, it goes down 10%. So if you plug in t into each of these, in this case, you'd get 20 times t is 400, right? So that's a really long time. Whereas here, if you do t is equal to 20, you divide that by 20, and that equals 1, which is perfect. Because that's saying, aha, 0.9 to the 1 means that it'll increase by 10% in 20 years. Okay, so in this case, D is the correct answer. Okay, last two problems of the day. Let's do this, guys. Let's finish some energy, and then we'll be hyped for the Thursday session, which will be the short answer. All right, 29. The incomplete table above summarizes the number of left-handed students and right-handed students by gender for 8th grade students at Kaisla Middle School. There are 5 times as many right-handed female students as there are left-handed female students. Okay, so there is 5 times as many right-handed. Okay, so that's times 5. Okay, and there are 9 times as many right-handed as there are left-handed male. Okay, so here is times 9. Okay. If there are a total of 18 left-handed students, which one has a close probability that a right-handed student selected at random is a female? Assume that none. Okay, so if let's say X students are, so X represents the number of female students who are left-handed. So the number of female students who are right-handed will be 5X. Okay, and now the number of male students, how can we represent that? Because we don't have any total numbers. We only have the total. We don't have actually the individual values, and there's no way we can know what that is. So the only way that we can fill this in is by doing 18 minus X. So if let's say there are 2 female left-handed students, 18 minus 2 will be 16. So that makes sense, right? Because 16 plus 2 will be 18. And so the same way here, we could subtract, we could say that it's going to be 9 times 18 minus X. Okay. But then we actually also know that it's going to be, that this is also going to be 122 minus 5X. Okay. Oh, so it actually helps us. We can solve for x, right? Because we know both those things are true. That it's 9 times 18 minus x, and it's also 122 minus 5x. So why don't we set those two equal to each other? 9 times 18 minus x is equal to 122 minus 5x. And if we solve for x, we can solve for the number of female left-handed students, and that will tell us everything. So 9 times 18 is 162 minus 9x is equal to 122 minus 5x. Let's add 9x to both sides. And let's also subtract 122 right away. So this crosses out, and we get 40 is equal to 4x. So x is equal to 10. So there are 10 female left-handed students. So what are they asking us? Which of the following is the closest probability that the right-handed student selected at random is female? Haha. So basically it's saying of the right-handed students, okay, so we have to find out target over sample size. So in our case, we're only sampling the right-handed students. So that's going to be out of 122. So what is the probability that they will be female? So we know that the right-handed students that are female is going to be 5 times x, which is 5 times 10, which is 50. So which of these is closest to 50 divided by 122? 0.4098. Nice. That was good. All right. Whew. On to the last problem of the day. Let's do this. I hope I can help you solve this one. I have never seen it before, so let's try it out. In the equations above, b and c are constants. If b is c minus 1/2, so if b is equal to c minus 0.5, which of the following is true? X, aha. So we have, actually, how many variables do we have? We have 4 variables and only 3 equations, right? We only have 4 variables and 3 equations. So that means that we can't really solve for each of the variables, but maybe we can somehow get a relationship here that will help us. All right, so we'll probably want to be substituting a bunch of stuff. 3x plus b, okay. Okay, so let's start. Maybe let's substitute b here and here. So I'm going to rewrite this equation. 3x plus c minus 0.5 is equal to 5x minus 7. All right, and so let's solve for c here. I'm going to subtract 3x, subtract 3x. All right, here, let me write that. Actually, here, let me write this entire thing here. Okay. 3x plus c minus 0.5 is equal to 5x minus 7. Subtract 3x. Add 0.5 right away. We're going to do them both simultaneously. Plus 0.5 minus 3x. Cross this out, cross that out. So c is equal to 2x minus 6.5. Okay, so we have that. So now let's maybe look at this equation down here, okay, and plug in c into, substitute c into this equation. So now we have 3y plus, and I'm going to substitute this value for c. So instead of c, I'm going to write 2x minus 6.5 is equal to, this is a y actually, sorry, this is a y, 5y minus 7. Okay, and so now we want to get x on one side and y on the other, right? Because all the solutions are x is. Okay, so let's get the x's on the left and all the y's on the other side. So I'm going to subtract 3y, and I'm going to add 6.5. So I'll subtract 3y and add 6.5. And so now this crosses out, this crosses out. So 2x is equal, what's 5y minus 3y? That's going to be 2y. And negative 7 plus 6.5 is negative 0.5. All right, so I'm almost done. The last thing I want to do is isolate x. So I'm going to divide everything by 2. All right, because I'm dividing it on the left side and on the right side. So this crosses out, this crosses out. So x is equal to y minus, and what is a half divided by 2? It's going to be equal to a fourth. So x is equal to y minus 1/4. Woo! So I want you to notice how long that took me, and I was actually going through it pretty fast. If you have no idea how to solve this, or it's your first time seeing like a 3-equation system of equations, this could probably take you like, I don't know, 5 minutes. So again, what I suggest is if you get this far in the test and you slow down, skip these problems, do not go into it, and go to the short answer portion. Do these first, because these are going to get easy again, and then once you have time at the end, come back to the hard ones. Okay, you don't want to waste time doing the hard questions when you can do the easy ones in just as quick or at quicker of a time. All right, so you're essentially, they're all worth the same number of points. So might as well do the easy ones, do them correctly, and then come back to the harder ones. All right, so that is my pro tip for the SATs. So yeah, so that is it for today's stream. If you have any questions or concerns or comments or recommendations or complaints, write it in the comments. Feel free. And as I mentioned earlier, for subscribers, I will be doing surprise subscriber lessons. So I won't be telling anybody. I'll just go on live, and you'll get an email if you're a subscriber, and you'll be able to ask me questions. It'll probably only be a few people in the chat. And the goal is 20 subs. So we're almost there. I'm at 17 right now as of this video. Hopefully you can help me get to 20. Tell all your friends who are studying for the SATs. And last thing is that I am not committed to the SAT forever. So if there is a topic that is more interesting, more relevant to you, could be the ACTs, just let me know, and I might change my topic to be the ACTs or some other test that I feel confident teaching over the next month or so. All right, so thank you for tuning in, and I'll be back on Thursday, August 3rd at 7 p.m. Eastern to finish up this test. All right, take care. Have a good night.